This is the video for Algebra 2B, Part 16, Task 4, Activity 3. So again, let's recall from Task 2 what independent events are. Independent events are not affected by previous events, okay? If we know something's occurred, it's not going to affect the probability of another event. So flipping a coin, each flip of a coin is independent of the next. The probability of the intersection of independent events is found by multiplying the individual probabilities. So the probability of A intersect B, or A and B, is simply the probability of A times the probability of B. But how do we calculate the probability of events that are dependent, that are not independent? This means that the events are affected. By previous events. So the multiplication rule for probability says that the probability of A intersect B for dependent events is the probability of A times the probability of B given A has occurred. So we have to do a conditional probability to calculate these probabilities. So let's look at whether we can decide how we can determine whether events are independent or dependent. So tossing a coin and spinning a spinner. Does tossing a coin affect spinning the spinner? No, they're two different things. I can toss a coin and spin a spinner. Whatever I get on the coin isn't going to affect what I get on the spinner. So these are independent events. Okay, they're not going to affect each other. How about getting a raise and purchasing a new car? If I get a raise, does that change the probability that I'm going to purchase a new car? Yeah. If I have more money, I'm probably more likely to purchase a car. So they're dependent events. They depend on each other. So let's do some calculations for probabilities here. A bag contains 8 white marbles, 4 green marbles, and 3 blue marbles. 2 marbles are selected at random without replacement. That means I'm going to pick a marble and I'm not going to put it back in the bag. I'm going to keep that marble out of the bag. So what's the probability that you select a blue marble and a white marble? So I'm going to say probability of B for blue intersect W for white. Now because I'm not replacing that marble, I'm not putting that marble back in the bag, these become dependent events. Whatever I choose as the first marble, that's going to affect the probability that I choose what I choose for the second marble. So let's do the probability of selecting a blue marble. So we have 8 white, 4 green, 3 blue. So 8 plus 4 plus 3 would give us 15. So we have a total of 15 outcomes. How many of those would give us a blue marble? 3 out of 15. Times, now for the second probability, I'm going to do a conditional probability. I'll write it up here. I want to know what's the probability that I select a white marble, knowing that I've already selected a blue marble. Now, if I've already selected a blue marble, I no longer have 15 total marbles. I now only have 14 marbles to choose from. And of those 14 marbles left in the bag, how many of them will give me a white? 8 of them. 8 will give me a white marble. Now you can actually do some reducing on these fractions. You can cross cancel if possible. I can reduce each one. 3/15 reduces, 3 goes into both. 1 over 5, 3 goes into 3 once, into 15 5 times. And 8/14 are both divisible by 2, so 8 divided by 2 is 4. 14 divided by 2 is 7. And then I can just multiply straight across. 4 out of 35. Now if you can go ahead and use a calculator on this. We're not making you multiply fractions in your head, but that's how you would. What is the probability that you select 2 green marbles? So green 1 and intersect green 2. Okay. So the probability that I select, the first marble I select is green. Again, I still have 15 marbles total in my bag now, so this is a different question. So I'm going back to a full bag of marbles. So 15 total marbles in there. 4 of them are green. Now this second probability is a conditional probability. Let me write it over here. What's the probability that the second marble is green given that the first marble is green as well? Well, again, I've selected a marble out of the bag, so I no longer have 15 marbles in the bag. I now have 14 marbles in the bag. Let me fix that. So I have 14 total marbles left in the bag. I've already selected a green marble, so I no longer have 4 to choose from. I only have 3 green marbles to choose from. So if we use our calculator, we would get a probability of 2/35. That's what it would reduce to. 2/35. And the last example with some notation, probability of A is 0.4, probability of B is 0.7, and the probability of B given A is 0.42. So find the probability of A intersect B, be the probability of A, so 0.4, times the intersection, because we're not told they're independent, so we have to assume that they aren't. So 0.4 times 0.42, you would get 0.168 when you multiply those. And that completes this video. Give the problems in activity 4 a try.